Okay, today we are going to finish up section 5.5 and we're going to start with a little review and then we're going to hit some of these sum to product sum formulas. So the first ones are just reviewing some of the half angle formulas, but they're asking you, notice, to work backwards instead. So notice that in these problems, instead of asking you to go from the half angle forward, we have problems where it's asking you to go backwards and to find the half angle. So we look at this and we see that we have the square root of 1 minus cosine 6x over 2. Well, that looks a lot like the half angle formula for sine. So I know that this is positive, and then basically that this is the sine of half of 6x. So it's the sine of 6x over 2, which is going to be the sine of 3x. Now, the thing is that this was very deliberately positive. We want to make sure that this stays positive. So to make sure that it's positive, we're going to put an absolute value around it to make sure that we get a positive value. Similarly, in number 2, we look at this, and hopefully we recognize this as the tangent formula. And again, we want this to be negative, and it's going to be half of 8x. So we know that this is going to be the tangent of 4x. We said we wanted it to be negative. So again, because we need it to be negative, we're going to put absolute value bars around the tangent of 4x so that whatever this is, we're going to then make sure that we have it negative. So that's kind of the little trick working backwards in those pieces, is to use the absolute value bars when you have to deal with that sign. Okay? All right, let's do another one with the half angle formula. It wants us to find the exact zeros of the function in the interval 0 to 2 pi. And I have the sine of x over 2 minus the cosine of x equals 0. So one thing I might want to do is rewrite this half angle using our first power of cosine here. If I use that, I can say that the sine of x over 2 is the same as 1 minus the square root of 1 minus cosine x over 2. And what I can maybe also do at the same time is maybe move that cosine x to the other side, so that way I can maybe do something to simplify this, because again, we have this square root. If we could get rid of that, that would be ideal. So to get rid of it, what we could do is we could square both sides there, and then that gives us 1 minus 2 cosine x over 2, the square root and the square cancel, and then we have equals cosine squared x. Well, that's looking a little better. We could multiply both sides by 2 to get 1 minus the cosine x equals 2 cosine squared x, and this is looking like a quadratic that maybe is factorable. So let's give it a whirl. So if we put everything to one side, I get 2 cosine squared x plus cosine x minus 1 equals 0. And now that it's in that quadratic form, maybe we can factor it. So I would need 2 cosine x and cosine x here. The nice thing about 1 is its only factors are 1 and negative 1 here. And to make a positive cosine x in the middle, my signs could look like this. And essentially that means, using zero product property, that the cosine of x is 1/2, and the cosine of x could be negative 1. So let's find the values that could make that true. Cosine is positive in quadrants 1 and 4. And this is going to be the pi over 3 family. So that'll be pi thirds and 5 pi thirds. And we know that cosine of x is negative 1 when x equals pi. Now we might be tempted to happy cloud, but we particularly have to be cautious about our solutions here because we did square and we could have potentially created some extraneous solutions. So let's just double check and substitute it into the original problem. So if I put pi thirds in, that's like the sine of pi 6, which is 1/2, minus the cosine of pi thirds, which is 1/2. So that gives me 0. So that checks out. Putting 5 pi thirds in, that would be like the sine of 5 pi 6, which is 1/2. Cosine of 5 pi thirds is 1/2. So 1/2 minus 1/2 again is 0. So we're good here. So let's put pi in. So that would be the sine of pi over 2, which is 1 minus. And then the cosine of pi is -1. And here we have that 1 minus -1 equals 0. This is not true. So there was an extraneous solution that popped up. So the only two valid solutions would be pi thirds and 5 pi thirds. Okay? So now we get into the brand new stuff. These are the product sum and sum to product formulas that you do not need to memorize. Yay, okay? So these first couple just want us to write the product as a sum or a difference. So you can see that this is a product, and we're going to use the product to sum formulas to turn this product into a sum. So we have these different formulas, and we can see that we're dealing with two signs being multiplied by each other. So we're going to use this first rule that's up here. Okay? So I'm going to stick the 6 in front, and the rule for the signs is that we'd have 1/2, and then we have the cosine of the first minus the second, so the cosine of 3x minus 2x minus the cosine of the sum of the two, so the cosine of 3x plus 2x. Okay, so essentially this 6 times 1/2 gives me 3. And then I have the 3x minus 2x just gives me x. And the 3x, whoops, that's a plus. And the 3x plus 2x gives me 5x. So I have 3 times cosine x minus cosine 5x. And that's all we've done. We've taken the product and we've written it as a sum or difference. Similarly, in number 5, we have a cosine times a sine, so we can use this rule that's right here. We don't have a coefficient in front this time, so we're just going to have 1/2. And then we're going to take the sine of the first and the second at the sum, so 3x plus 5x, and then minus the sine of the difference of those two pieces. So I have 1/2 times the sine of 3x plus 5x is 8x, minus the sine of 3x minus 5x is -2x. Now, I'm not going to leave it like that, because what I can do when I have a negative angle here is I can use my even and odd properties. And I know since sine is an odd function that this is really going to be the opposite, so I can rewrite this as 1/2 times the sine of 8x and then plus the sine of 2x. So again, from here to here, I use the even odd properties to clean that up a little bit. And that's all she wrote for that one. Okay, so again, we took the product and we wrote it as a sum or difference. Okay. In the next question, it says to write the sum or difference as a product, and in some of these, you guys, it's really tempting to evaluate. So I'm going to change the instructions a little bit. I'm going to say write the sum or difference as the product of two trig functions. And you'll see what I mean as we do this. Essentially, it's going to be real tempting to evaluate, but when our instructions are telling us to rewrite the sum as a product, then we want to leave it in that product and not evaluate. Okay, so just make sure we're looking at the directions there. Okay, so again, we're going to rewrite this sum as a product. So what we can do is we can use the sum to product rules. And notice that this matches this piece here. But notice that the x in the formula is x plus pi over 2. And the y in the formula is x minus pi over 2. So there's going to be a lot of stuff that's being added and subtracted over here when we use that formula. Okay? So let's try to use that formula, however, and what we do is we take 2 times the sine of, and then what we're going to do is add these two pieces in the numerator. So that's x plus pi over 2 plus x minus pi over 2, all over 2. And then we have the cosine of the difference of these two all over 2. So we'd have x plus pi over 2 minus that x minus pi over 2 over 2. So that's using that formula. It's like a lot of extra addition than it looks like, just because the x and the y that were in the formula were really already sums in this problem. Okay, so let's clean this up. Notice that the positive pi over 2 and negative pi over 2 cancel, so I really just have 2x over 2. And here, if I distribute this negative, I'm going to have x and negative x cancel. And then I have pi over 2 plus pi over 2, which is really just pi. And so then I have that pi in the numerator and then the 2 in the denominator. And then I could simplify this a little bit. I have 2 times the sine of x times the cosine of pi over 2. This is where it's tempting to evaluate, right? Like we totally want to evaluate the cosine of pi over 2. But notice this is being now written as the product of two trig functions, right? We have 2 times the sine of x and the cosine of pi over 2. So read the directions and don't oversimplify, okay? So again, if the question asks you to write it as a product, then your final answer should be a product, okay? Maybe then like later we could ask you to evaluate it, but just make sure you're careful of the directions, okay? All right, so we're done with page 1. So let's go to page 2, where we're going to practice finding zeros and solving. In number 7, we have the cosine of 2x minus the cosine of 6x equals 0. So what we might be able to do is to use the zero product property. It would be really nice if this was a product instead. So that's where we can use the sum to product formula to help us out. And notice that this is going to look very much like this. We have the cosine of 2x minus the cosine of 6x, so we can use this formula to kind of help us out. So that formula tells us that we're going to take negative 2 times the sine of, and then we add those two pieces together and divide by 2, and then we have the sine of the difference over 2. So I've just used that to write use the sum to product rule. And we can clean this up a little bit. This is going to be a 4x, and this is going to be a negative 2x. And then again, I'll use my even odd properties. I'll take this negative, apply it here, and so I have 2 times the sine of 4x times the sine of 2x equals 0. And now I can use the zero product property. And essentially I can say, all right, well, let's have the sine of 4x be 0, and let's have the sine of 2x be 0. And let's think of all the places where the sign could be 0. So, and because of the 4x, we'll have to go around the circle 4 times. So we have 0 and pi, 2 pi and 3 pi, 4 pi and 5 pi, 6 pi and 7 pi, and then we're going to divide all of those by 4. So I have 0, pi fourths, pi halves, 3 pi fourths, pi, 5 pi fourths, 3 pi halves, and 7 pi fourths. So those are all the ones that we have for when the sine of 4x equals 0. So now if we look at the sine of 2x equals 0, we would want to go around the circle twice. So we'd have 0, pi, 2 pi, and 3 pi. But as we solve, notice if I divide 0 by 2, I get 0. Pi by 2, I get pi halves. 2 pi by 2, I get pi. And 3 pi by 2, I get the 3 pi halves. So notice all of these end up being repeat. Okay, so these are going to be our solutions. We'd have 0, pi fourths, pi halves, 3 pi fourths, pi, 5 pi fourths, 3 pi over 2, and 7 pi over 4. Okay. All right. So let's look at number 8. And so another tactic that we could do in number 8 is that we might see that this is the difference of squares, and maybe we could factor as the difference of squares in number 8. So that means that we can use the conjugates. I can take cosine 3x plus cosine x, and then cosine 3x minus cosine x, and set that equal to 0. Now, how does that help? Well, right now it doesn't do much of anything. It is a product, but the problem is that we have the sums within the product. So what we could do is, again, we could use the sum to product formulas on each of these pieces. So notice that this first one matches this guy right here. So we can use that formula on this guy. And because we're subtracting cosine here, we can use that formula on the second one. So let's put those pieces in. So I have 2 times the cosine of the sum of these over 2. And then we have the cosine of the difference of these over 2. So that's essentially what this first piece turned into, okay? So my 3x and my x are those little pieces. And now we can do the same thing with this factor and turn that into a product. So I have -2, and then I have the sine of, again, the sum of them over 2, and then the sine of the difference of those over 2. I still have that equals 0 over there. So we can clean this up. Notice now this is all multiplication though, you guys. So now we're like almost ready to use the zero product property. So I'm going to take the coefficients, 2 times -2, just put those together. And then I'll just make sure I'm simplifying these okay. So that's going to be cosine of 2x. This is 2x over 2, so cosine of x. We already compensated this -2 over here. So this is going to be the sine of 2x and the sine of x. So essentially we have all of these different factors that we can then set equal to 0, and we can try to solve. So the first one we have is that the cosine of 2x equals 0. So we have to go around the circle twice, and cosine cosine is 0 at pi over 2 and at 3 pi over 2. So going around the circle again, that would be at 5 pi over 2 and 7 pi over 2. So then dividing by 2, the x values would be pi fourths, 3 pi fourths, 5 pi fourths, 7 pi fourths. So those are my possibilities for this factor. But we have a couple more factors. We also want to know when cosine can be of x is 0. So we know that that's true at pi over 2 and 3 pi over 2. Notice that doesn't repeat any of these. So I'm going to write those down here too, that we have pi over 2 and 3 pi over 2 that are also possibilities because of this cosine of x equal to 0. So now I'll set the sine of 2x equal to 0. And again, we want to know when sine of x is 0. Well, that's 0 and pi. but we want to go around the circle a couple times, so we have 2 pi and 3 pi. And when I'm solving, I want to divide by 2, so 0 divided by 2 is 0. Pi over 2, we've already done. 2 pi over 2 would be pi. We haven't done that one yet. And then 3 pi over 2 we've done already. Okay? Lastly, we have the sine of x equals 0. And again, that means that x could be 0 or pi, but notice that like all of these repeat each other. So these are going to be my solutions. All right. So now we've got some identities to verify. These actually aren't too bad. In number 9, I didn't originally do number 9 this way, but I want to show it to you guys because I think this is a cool thing to think about doing. So number 9 has that secant of 2 theta equals secant squared theta over 2 minus secant squared theta. And I wouldn't have, I'm not going to lie, I wouldn't have thought of this on my own. But now that I have seen this trick, it's something that I can keep in my back pocket. What if I start on the right side and I multiply by cosine square theta over cosine square theta? What that's going to do is basically the secant square theta times cosine square theta just becomes 1. Now this becomes 2 cosine square theta. And then again, secant squared theta times cosine squared theta is 1. And what I've done then is get rid of the secant part and put it in terms of cosine, which we do have some formulas that have that in it, don't we? Oh my goodness, this looks like the double angle formula, one of the double angle formulas for cosine. So we could turn this into 1 over cosine of 2 theta. And isn't that then the secant of 2 theta? So I like that tactic of multiplying by the reciprocal function to kind of get rid of that. It really made it a lot cleaner. So that's just a little trick for number 9. Number 10, we have the sine of 4b, beta, equals 4 times the sine of beta cosine beta times 1 minus 2 sine squared beta. Whew. All right, so I know that I want to maybe turn this into 4 beta somehow. So I look here and I notice this sine beta cosine beta. If I had 2 sine beta cosine beta, that's a double angle. And so what I'm going to do is think about this 4 as 2 times 2 sine beta cosine beta. So all I did was turn that 4 into 2 times 2. And for right now, I'm just going to leave this guy here also. And really what I can do then is use the double angle formulas. So this is the double angle formula for sine. So I can turn that into the sine of 2 beta. And this is a double angle formula for cosine, isn't it? So this is the cosine of 2 beta. And look, I have the sine and cosine multiplied together again with a 2 in front of it. I can use the double angle formula again. This time though, I'm doubling the 2b, and so that gives me the sine of 4 beta. Oh yay, and that's what we wanted. So in your problems, look to see if any of those formulas pop out at you so that you can use them as part of your steps. Okay, page 2, check. All right, page 3, number 11. Oh, I like this one because it's short. So in number 11, we have cosine x to the 4th minus sine x to the 4th, and we want to show that that's equal to the cosine of 2x. Well, let's deal with this. This, again, is the difference of squares. So I could put this as cosine squared x plus sine squared x times cosine squared x minus sine squared x, and see if that helps out. Well, look, this is our very favorite, well, I don't know about you, but it's my very favorite Pythagorean identity, that this is just the same as 1. And then I still have this cosine squared x minus sine squared x. But wait a minute, this is an identity too, isn't it? This is one of the double angle formulas for cosine. So I'll double this x, so that's going to be the cosine of 2x. And that's what I wanted. So I've shown that identity. Okay. Phew. Alrighty. Number 12. When we see something like this, again, notice that I have this difference. And so here what I can do is I can use the sum to product rules to maybe help us get factors so that we can cancel things out. So notice that this is a cosine minus a cosine. So that's where we have negative 2 times the sine of the sum of the two angles times the sine of the difference of the two angles. So that's the numerator, and that's all over this 2 sine 3x. So again, I'm just using this sum to product rule that's on the very bottom. And I'm using 4x and 2x as those values. Okay, so that means that I'm going to have 4x plus 2x is 6x over 2 is 3x. And 4x minus 2x is 2x over 2 is just x. And then in the denominator, I still have 2 times the sine of 3x. Oh my goodness, look, I can cancel out the sine of 3x. I can cancel out these 2's. So let's see, I'm left with negative sine x. Yay, and that's what we wanted. I love these identities. I know, I have issues. Okay, so that's something that you can do, a way that you can attack number 12. Alrighty. Okay, 2 more. Number 13. We have the sine of x plus y over cosine x cosine y. We want to show that that's equal to tangent x plus tangent y. Well, I feel that the left side's a little more complicated. And once again, what I want to do here is notice that I can use the sum and difference formula, not the sum to product, because the sum to product is when you have 2 different trig functions that you're adding or subtracting. The sum and difference formula is when you have 1 trig function and you're basically summing 2 angles together. So let's think back to 5.4 when we were doing those, and let's write the rule for sine. So remember, the rule for sine is that we'd have sine x cosine y plus sine y cosine x. So we can change that, and here we still have over cosine x cosine y. Well, one thing we can do, because we have 1 denominator and several terms, is we can separate this into 2 different terms and see if that's helpful. So I could take the sine of x cosine y over cosine x cosine y, and then add the next term, the sine of y cosine of x over the cosine of x cosine of y. So again, all I did is just separate it into 2 different terms. And that's really handy because we see that these cosine y's cancel. And so the sine of x over cosine of x, I could rewrite that as tangent x. Okay. And in the second term, the cosine of x and cosine of x cancel out. And that leaves me with the sine of y over the cosine of y. So that's going to be the tangent of y. And what do you know? That's what they wanted us to show. So we're all done with number 13. Okay, all right, so now we're on to number 14. And if I look at 14, I understand that this looks like the more complicated side, and you could totally use that side, but one of the things that we've been looking at is this idea of the sum, like the sum and difference problems. And so the way that I started this one is I thought about 3x as 2x plus x. And then I'm going to use the sum and difference formulas for that. So remember, for cosine, it's going to be cosine 2x cosine x minus sine 2x sine x. Okay? So I use the sum and difference formula, and I noticed that in the desired answer, I don't have any double angles. So maybe I could break it up using the double angle formula. Cosine, we have a choice, and notice that we have cosine in our answer, so let's choose the one that's only with cosine. So this cosine 2x is going to turn into 2 cosine squared x minus 1. So we still have that times the cosine of x. And then now we also want to maybe change this double, this angle here, the sine of 2x. So we're going to have to change that to 2 sine x cosine x. And then we still have this sine of x that's over here. And you might say, well, that didn't really help because we still have these sine of x's and we'd want to get rid of them, but we'll see. We'll see if we can get rid of them. So let's multiply stuff here. This gives me, if I distribute this cosine, 2 cosine cubed x minus 2 cosine x. Just kidding, you're not distributing the 2. 2 cosine cubed x, then just minus cosine of x. And then over here, I've got 2 sine squared x cosine x. Okay. So it's looking a little bit better. Okay. So now the only thing, because again we do want cosines, but we need to get rid of the sine squared x. How could we do that? Someone might say, well, you could use the power reducing formula. We could, but I think there's a nicer way. So what I'm going to do is I'm going to use the Pythagorean identity. And that's a way that I could get rid of that. And again, we don't necessarily want to reduce the power. We just want to get rid of the sine squared x. So I can change that into 1 minus cosine squared x. I'm sorry, it was crooked. And let's maybe distribute over there as well. So these terms are pretty much the same. I've got 2 cosine cubed x minus cosine x. And then essentially, I don't know if I want to do all these steps at once, since I'm not there to gauge how y'all are doing. So I'm going to start by distributing this cosine x. So I have this cosine x, and then minus cosine cubed x. And now maybe I'll distribute that 2. No, the negative 2. So then distributing the negative 2, I get negative 2 cosine x plus 2 cosine cubed x. And look, now we finally only have cosines, and let's see what happens when we combine like terms. Putting these together, I get 4 cosine x cubed, and putting these guys together, I get minus 3 cosine x. Oh, and yay, thank goodness, that is what we wanted. We had to use a lot of identities on that one, didn't we? A lot of formulas. So we're all set with that. So that's a little bit about the product to sum to product formulas, as well as the review of things like sum and difference, all the ones that we did, half angle. So that's it. Thank you. Good luck.